Welcome to This Explainer. Today, we're diving into something that literally sounds like it's straight out of a sci-fi movie. We are embarking on an extreme thought experiment. I want you to picture a world where almost every single horizon you look at is just sand, rock, and dust. We're going to take our planet, take current environmental trends, and push them to their absolute terrifying limit in a massive scientific stress test.
So what if Earth was actually 90% sand and rock? Imagine this catastrophic extreme for a second. Think about a planet where our lush, sprawling forests have shrunk down into these tiny, isolated little patches. A world where once mighty rivers, they're just seasonal memories. Croplands are failing across entire continents. Now, I know it sounds exactly like a Hollywood blockbuster, but here's the crazy part. The underlying mechanics making this happen are actually at work today.
Section 1. The 90% desert Earth.
Okay, to really wrap our heads around this 90% stress test, we actually need to define what a desert is, because, we aren't just talking about rolling cinematic sand dunes here. Fundamentally, scientifically speaking, a desert is any region receiving less than 250 millimeters of annual precipitation. Actually, fun fact, that is exactly why Antarctica is technically the largest desert on Earth. So when we talk about a completely desertified planet, it's really a story about the total collapse of the water cycle. And just to be super clear right up front, we're using this 90% scenario as a scientific stress test to understand the limits of our life support systems. This isn't some strict, inevitable prediction of tomorrow.
Now, what's really interesting about this extreme scenario is the massive jump in numbers we'd see. Right now, today, Earth is already about 1/3 drylands. That includes arid, semi-arid, and dry subhuman regions. But in our 90% scenario, 57% of the entire planet becomes newly desertified land. It's wild to think about. Ecosystems would just completely collapse into these hyper-arid states, and that leaves us with only a tiny 10% sliver of habitable green zones scattered across the entire globe.
Section 2. How aridification accelerates.
So how exactly does a planetary life support system just break down? Well, as global temperatures rise, that warming actually pushes our planet's dry air belts. They're known as Hadley cells. It pushes them outward. This expands arid zones right toward the mid-latitudes. And this sci-fi premise, it actually anchors directly into a very urgent reality. The United Nations Convention to Combat Desertification reports that up to 40% of global land is already degraded right now. 40%. And this is being driven by us. Human actions like overgrazing, unsustainable farming, deforestation, poor irrigation. We are quite literally scraping away fertile topsoil way faster than nature can ever regenerate it.
And all of that creates a vicious positive feedback loop. Once aridification starts, it acts like a malfunctioning machine that naturally accelerates its own destruction. Think about it like a massive domino effect. First, you have less vegetation, which means you get less localized rainfall. Less rainfall obviously leads to even more vegetation loss. Then, that exposes more bare soil, which just sits there and absorbs more heat, driving up evaporation, and boom, the cycle starts all over again, just faster and harsher.
Section 3. Global systems in collapse. If we let that feedback loop run completely unchecked, we'd witness the cascading collapse of all our interconnected global systems. Contrast our lush, beautiful reality today with this dusty hypothetical. Tropical rainforests, literally the richest ecosystems on the planet, would shrink dramatically into these tiny, fragmented, isolated refuges, which would severely accelerate mass extinctions. Hydrologically speaking, rivers would dry up completely or just flow seasonally. Wetlands? Gone. We would see an Aral Sea-style collapse of shrinking lakes, but on a massive planetary scale.
This all builds into a total, catastrophic breakdown of the soil system itself. You see, healthy soil isn't just dirt, it's practically alive. It relies on moisture, organic matter, and microbial life. But in extreme desertification, that soil becomes biologically dead. Without plant roots acting like anchors to hold it all together, erosion becomes completely irreversible. And you know what that means? Massive atmospheric dust storms. They would become a totally normal, everyday global occurrence, severely wrecking air quality and disrupting climate regulation even further.
And this environmental collapse connects directly, and I mean directly, to human survival. The vast wheat, rice, and maize belts that feed our world today would shrink drastically. Grazing land would disappear almost entirely, which means meat becomes incredibly rare. We'd be looking at extreme global food insecurity and insane price volatility. And on top of all that, human health would absolutely plummet. We're talking severe heat stress, hyperthermia, and a massive spike in respiratory diseases from breathing in all that dust, ultimately forcing hundreds of millions of people into climate migration.
Section 4. Humanity's survival strategies. Okay, let's dive into this. Despite these incredibly severe challenges, humanity wouldn't just sit back passively. Our survival would entirely depend on some extreme technological lifelines. We would have to lean heavily on massive desalination plants, all powered by renewable energy. Agriculture? It would be forced indoors into these massive vertical hydroponic farms using genetically engineered, drought-resistant crops. We'd be utilizing atmospheric water harvesting tech just to pull whatever moisture we could out of the air. Ultimately, human populations would likely have to retreat into heavily insulated, climate-controlled megacities, maybe even underground, where water recycling systems have to hit near 100% efficiency just to keep everyone alive.
Economically and geopolitically, the world as we know it would be completely unrecognizable. Agriculture would become entirely industrialized. And water becomes a globally traded strategic commodity. It literally becomes the single most valuable resource on planet Earth. Obviously, this would inevitably lead to fierce, intense competition over the few remaining freshwater basins. We'd see border tensions skyrocketing and immense, constant risks of conflict over whatever tiny plots of arable land are left.
Section 5. The real scientific consensus.
All right, let's snap back from our extreme hypothetical what if and look at the actual science journalism. What is happening today? First off, we have to understand recovery timescales. Scientific evidence shows that partial recovery from degradation is totally possible. Reforestation can restore local rainfall, and regenerative agriculture can absolutely rebuild soil. But that takes decades, sometimes centuries. Reversing extreme global desertification, though, that takes centuries to millennia. And unfortunately, the massive loss of biodiversity and the destruction of certain soil ecosystems are effectively irreversible on a human timescale.
So, the crucial point is this. Current climate models do not project Earth becoming a uniform 90% desert. We aren't quite headed for a sci-fi sand planet, but the drylands are expected to expand significantly. The very real risks, which have been thoroughly identified by both the IPCC and the UNCCD, include accelerating soil degradation, increasing drought frequency, and severe water scarcity that, frankly, is already affecting billions of people today. Instead of one giant global desert, what we are really facing are severe, localized, many desertification crises in places like the Mediterranean, parts of the Americas, and Central Asia.
Which brings us to this incredibly profound lesson from the scientific community. Earth does not suddenly become a desert. It becomes one field, one river basin, one region at a time. The underlying processes of soil degradation and water scarcity are completely real. They are active and they are creeping across the globe right now as we speak.
The 90% desert Earth is ultimately a warning from our own climate system. The outcome depends entirely on the decisions we make in the coming decades. Will we embrace regenerative practices and stabilize our life support systems? Or will we continue business as usual and just let the aridification accelerate? It's a critical question, and I hope it's one you carry with you as you look at the environment around you today. Thank you so much for exploring this explainer with me.